To solve a quadratic inequality like this one, okay, so again, quadratic inequality, we're going to use the same method that we're going to use for most inequality types, which is to first think about the equation. So first, solve the corresponding equation. Oh, and actually, I guess maybe that's sort of second. Very first thing I'm going to do is just move this over to the other side. That's not 0. There we go. Because most of our quadratic solving methods rely on comparing to 0, quadratic formula, factoring, all those things we need to be comparing to 0. So that's why I'm doing that first. Okay, now I'm going to solve the equation. So x squared plus 7x plus 10 equals 0. Again, whatever solution method you want to use here, you can use the quadratic formula. You could complete the square, do the square root property thing. This one happens to factor. So for the sake of time, I'm just going to do that real quick. And then because we have a product equal to 0, I can split. Okay, fine. For more on this, there's a separate video on solving quadratics. But okay, there you go. So -2 and -5 are the solutions to the equation. That means x equals -2 or x equals -5 makes the left hand of this thing 0. So that tells us where this is equal to 0. Now what we want to figure out is where it's less than 0. So now we'll solve the inequality. And I'm going to kind of look at two ways of doing this, but at the same time. So as usual, I'm just going to draw myself a little x-axis number line to keep track of things. I'm going to mark -5 and -2 as the two places where these things are exactly equal. That means everywhere else they're not equal, and the places that it can change from, being the inequality from being, true to false or vice versa are at these 2 points. So what I need to know is what happens around and between those. So I can either think about this graphically. This is a quadratic with positive leading coefficients, so it opens up, which means it has to look something like this then, with how it relates to the x-axis. Again, it's opening upward, and we just figured out that it's equal to 0 at these 2 points. So if I'm looking for where it's less than 0, that would not be true here or here because the graph is sitting above the x-axis, but would be true on the center section. So if you're, comfortable with that idea, then that's great. Roll with that. If you're not 100% sold on that, then we can also do this same thing by picking some test values to plug in. It's going to, take just a little bit more time, but if you feel more confident or like that's more concrete, then that's great. Okay, so I'm going to plug 0 in, 0 squared plus 7 times 0 plus 10, which is 10. The question is 10 less than 0? The answer is no. -4. So 16 minus 28 plus 10 is -2. Is -2 less than or equal to 0? The answer is yes. And then -6. 7 times -6 plus 10. Oh boy. Okay, 4, I think, if I did that right. Which is not true. So again, as with other places we've seen inequalities, basically just looking for a true or false on each of these intervals. Again, the graph would look something like this. And the question would be, does it sit below the x-axis? So you can get that information either way. And then lastly, write our solution set. Okay, the solution set here is everywhere we decided that inequality was true, which is everywhere between -5 and -2. And because the inequality included the or equal to bit, those endpoints should be closed. So -5 to -2, closed interval. Okay, that's it. That's really all we need to do to solve a quadratic inequality. Again, start by solving the equation um, using whatever equation method you want to use. I factored. You could use quadratic formula instead. Solve the inequality by either thinking about it graphically. I didn't draw that very well. Thinking about it graphically or by testing points, and then write down what that tells you about the solution set. Hope that helps. Please let me know if you have any questions.